Okay, so we want to talk a little bit about calculating medication doses. First of all, I want you to understand you have to read your label carefully and make sure you're working with the correct medication. Um, the next problems that we're going to do, I'm going to teach you how to do a ratio, proportion, and dimensional analysis, but you're actually looking at a prescription order and also from the physician, like what is the physician requesting? And then we're also going to look at a label, like the medication label. So as pharm techs, we must calculate the amount of medication to be given to the patient, both in individual doses, like what are they taking at this moment, and then the entire amount of dose, which is like a day supply. Like how much are they going to need for the day? How much are they going to need to fill their prescription? So there's two ways we can look at that. Sometimes we need to know how many, especially if we're doing like an oral dose, a liquid, we need to know how many milliliters to give them for that specific dose, that specific moment. And then we also need to know how much do we need to send home with them so they have enough to take the medication for the whole time. So pay close attention to the units of medication, the label. Like, is it, are we measuring in milligrams? Are we measuring in grams? Are we measuring in teaspoons, tablespoons, tablets, capsules? Like how many tablets, how many capsules? All of those are units of a medication, and you need to make sure that the dose required matches the dose provided. So if the physician says, I want zero point 0.2 grams of medication A, and your bottle it says in milligrams, you need to make sure you're converting that. And we haven't gotten to conversions yet. We're going to do that in module 2. So for today, what we're going to learn today, you are not going to be doing any conversions yet. If a pharm tech is ever unsure of their calculations, like you're not really sure if you got the right answer, it is important to have it reviewed by a senior technician or the pharmacist to ensure that the proper dose is given to a patient. Never just think you got it right and assume like, oh, that's close enough. It's never close enough. It has to be exact. And I do believe most places when you do pharmacy calculations, especially in institutional, they usually do a tech to tech check or a tech to pharmacy check. So remember, dose refers to the amount of medication, dose refers to the amount of medication given at a single time, and dosage refers to the amount of medication for the physician's entire order. So those are the differences. So you need to keep those words in mind because we are going to be starting to do word problems and it can get a little confusing. So there are two methods to calculate dosing, dose or dosage, and we can do ratio proportion or we can do dimensional analysis. So first we're going to start with ratio proportion. And I want to start by saying calculating using ratio proportion. First of all, you got to understand what a ratio is. So let's take a look at that. Okay, so here is our some math that we're going to take a look at. So a ratio is a numerical representation of the relationship between two parts of the whole or between one part of the whole. It's really like a fraction. It's written like a fraction. It's written like this. And a lot of times when you guys see ratio, you think of it being written like this. It can also be written as a fraction. It's one part of two parts. One half is one part of two parts. The proportion is an expression of equality between between ratios. So how equal are they? So we want to see how proportional these ratios are to each other. So an example in relation to medication is we can do 1 to 100, one part of drug to 100 parts of a diluent or a solution is one way you can look at that. Or you can look at 250 milligrams per one tablet or one tablet to 250 milligrams. Um, 500 milligrams to 20 milliliters or 20 milliliters to 500 milligrams. I want to point out this. When we're measuring in milligrams or grams, we are typically measuring weight. It's usually a solid, it's a measuring in weight. But when we look at things like milliliters or liters, we're looking at volume. It's like we're measuring a liquid. Usually it's not, this is usually a solid, usually, not always, and this is usually a liquid. Not always, but usually a liquid. So remember weight and volume and the difference in that. So that's ratio proportions. We're basically taking a ratio and we're looking at these two numbers and we're going to see how are they proportionate to each other. So let's take a problem. Let's take a look at a problem here. There is a 4 to 100 solution. If I look at this, usually we assume in pharmacy that we are measuring in what I call weight over volume, okay? So remember, what are we typically measuring when we look at weight? When I look at weight, I am measuring in grams or milligrams. Usually, that's most common, okay? So the first number, this is a weight over volume problem. It's weight over volume. So, because we have 100 of solution and for what? But usually in pharmacy, we make the assumption that that is grams. So it has 4 grams of active ingredient to 100 milliliters of solution. Okay, that's what it's saying in this ratio. If I ever saw that on a vial or a prescription label, a medication label, I'm going to assume that it's 4 grams to 100 milliliters of solution. So if our question says how much active ingredient would there be in 500 milliliters of solution, we can figure that out, and we can figure it out by the process of ratio proportion. But I want to give you a rule with ratio proportion. There's a few things you must know. The few things you must know is when calculating using ratio proportions, do you have 3 parts out of 4 of the information to solve the problem? You need 3 pieces of information. And to set up the problem with matched units. So when I say matched units, what I'm saying is the numerator must match and the denominator units must match. So if in the numerator we have grams, we need to make sure both of the ratios that we are comparing to see if they're proportional have grams. And same thing with the denominator. If we're comparing and they have grams or milliliters, we want to make sure they match, because if they don't, we're not proportional. So we got to make sure those units match each other. And if they don't, we have to convert them. And then in your 4th piece of information, that's what you're calculating for. So if you have 3 pieces right here, 3 pieces out of 4 of the information, you can solve using ratio proportion. Okay, so let's go back to our problem. So remember, I have to have 3 parts out of 4. Well, I know I have a solution that's 4 grams out of 100 milliliters of solution. I know that. So I need to figure out how much active ingredient would there be in 500 milliliters of solution. Well, I have milliliters and milliliters. So by looking at my units, I know that I want to put my unit on the bottom because it has to match. My numerators and my denominators have to match. So I'm going to set this equal to 500 milliliters of solution. Now do I have 3 parts out of 4? 1, 2, 3, yes, and here's my 4th one. So this is what I'm solving for. I'm going to figure out how much active ingredient would there be, okay? So the way I do a ratio and proportion, I call it a bat and ball. I cross multiply and divide. So I'm going to cross multiply the 2 numbers that I have which that's my bat, and I'm going to divide by my ball. So multiply by my bat, divide by my ball. So 500 times 4 divided by 100 milliliters. And you can type this in your calculator if you want, and I'll go ahead and do it so you guys can see it. I'm not sure if you can see my calculator, but I'm going to do 4 times 500 equals, and I'm going to divide by 100, and that ends up being 20. Okay, so my answer is 20 grams is my answer for that problem. There are 20 grams in 500 milliliter solution, and that is equivalent, that is proportional to 4 grams over 100 milliliters. And that's basically all it's saying, is when you're calculating pharmacy math, ratio and proportion work really well to calculate dosing, because we're really looking at fractions that are, or ratios that are proportionate to each other. So let's take a look at some other problems. So let's take a look at this one. This is a prescription or a medication label, Diovan. Okay, valsartan is the drug name. We can look at this prescription label, and can you tell me how many milligrams are in one tablet? Correct, 40. 40 milligrams per tablet. How many tablets are in this vial? Well, if you look at the prescription or the medication label, it says 30 scored tablets. So that means there's 30 tablets in this bottle, and each tablet is 40 milligrams. So what is our ratio here? What is the ratio of Diovan tablets? So what it's saying, every 40 milligrams to one tablet. That's what it's saying. That is our ratio, 40 milligrams to one tablet. So how many milligrams of Diovan is in this whole bottle? We're looking at the whole bottle. So do we have 3 pieces of information out of 4? What 3 pieces of information do we have? Well, 1, we know there are 40 milligrams. We know that's per tablet. And we know there's 30 tablets in a bottle. So we have 3 pieces out of 4. We need to figure out how many milligrams are in the total bottle. So let's set this up as a ratio proportion. Our ratio is 40 milligrams per 1 tablet. And we have 30 tablets, correct? So now we need to figure out our milligrams, and that's what it says in our problem, how many milligrams. So we're going to do our bat and ball. We're going to cross multiply and divide. So if you take calculator, and I have my answers written down here, but I'm going to do it on the calculator so you guys can see it. 40 times 30 equals 112 or 1,200, and we're going to divide by 1. Well, anything divided by 1 is the same, but I'll go ahead and do that. So our answer is 1,200 milligrams. That's the total amount in that vial. And that's what the question was asking. So there's your answer to your problem. Let's take a look at the next one. We're looking at trileptal, oxcarbazepine. This is an oral suspension. Okay, so it says that it's oral. So we have a weight over volume problem. We look at there's 300 milligrams per 5 milliliters. So my first question is, what's your ratio? What is your ratio on this label? Well, it's 300 milligrams to 5 milliliters. That's our ratio. So it's asking how many milligrams of trileptal are in this oral suspension. So it's saying how many milligrams are in this whole bottle of oral suspension. Well, how much is in the trileptal bottle? What's the total volume in this bottle? Does it say on this label? Yes, it does. It says that there are 100 milliliters in this bottle. So do we have 3 parts out of 4? Yes, we do. Okay, so let's take a look at that. We are going to set it up by putting 300 milligrams per 5 milliliters, because that's our first ratio. And we are trying to figure out milligrams, right? So we know what's going to go on the bottom are milliliters. So we know that there's 100 milliliters in this total vial, in the whole vial. So what is our milligrams? And we're going to do the bat and ball. We're going to cross multiply and divide. So let's grab our calculator. Let's take a look. 300 times 100 equals, let's try that again, 300 times 100 equals 30,000, and we're going to divide that by 5. And if I divide that by 5, I get 6,000 milligrams. And that's our answer. That's the total volume or dosage in that whole vial. Okay, so that's it for today.